Hey everybody, so today we're going to use the quadratic formula to solve quadratics. You know the quadratic formula, you know the song, so today is about practicing it and talking a little bit about the kinds of answers we get. So what I strongly suggest you do is get your quadratic formula in your cumulative notes with all four of the examples. You do not have to watch the entire video. I would write an example down, maybe watch me go through the first one, get the second example down, pause, do it, make sure you get the same answers as I do, and so on. So that you have good notes and good examples in your notes, but you don't have to watch the whole thing if you already know how to use it well. So let's just go through some. And first of all, let's write the quadratic formula. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you need to remember that this works when your quadratic equation is in the form ax squared plus bx plus c equals 0. So you have to have your equation set equal to 0 and in a good order, and then a is your coefficient on x squared, b is your coefficient on x, and c is your constant term, which is also your y-intercept or your initial condition. So let's go through some examples. The first quadratic we'll solve is x squared plus 2x minus 3 equals 0. Okay, so we're going to practice with the quadratic formula today, whether things are factorable or not, just so that you can see the different kinds of results and see the process one more time. So here, a is 1, b is 2, and c is negative 3. So we're going to plug into your formula. X equals the negative value of b, so here that's negative 2, plus or minus the square root of b squared, 2 squared is 4, minus 4 times a is 1, times c is negative 3, all over 2 times a, 2 times 1 is 2. So that's the substitution you should show me. You don't need to show me the b squared, the number b squared. You can do that in your head most of the time. Now, the thing I don't like about the quadratic formula is it's really easy to make mistakes underneath that square root with this negative sign and subtraction. So you have to be super careful. So here you really have negative 4 times 1, which is negative 4, times negative 3, which is positive 12. And then you clean it up from there. So x is negative 2 plus or minus the square root of 4 plus 12 is 16, all over 2, and go as far as you can. So x is negative 2 plus or minus, well, the square root of 16 is 4, all over 2. And since I have nice numbers, nice rational numbers, you can simplify further. So break up your roots. So we have x is negative 2 plus 4 over 2, and we have x is negative 2 minus 4, all over 2. Negative 2 plus 4 is positive 2, divided by 2 is 1. Negative 2 minus 4 is negative 6, divided by 2 is negative 3. So here your roots are 1 and negative 3. You can write it like that in your set notation. You can just say x is equal to 1 and negative 3. You can write it however you'd like. You can break them up as x equals, as long as you see your two roots. Let me autofocus that for you. So notice what happened here. I got really pretty answers, rational answers, integer answers as a matter of fact. So this means this really was a factorable problem. Again, I just wanted to show you the process of the quadratic formula with nice numbers before we moved into anything yuckier. Notice that the number under your square root was a perfect square, and that is why we ended up with nice numbers. I can simplify a perfect square, so my roots become rational. Okay, let's do a couple more examples. So for our second example, we'll solve x squared plus 3x equals 5. So the first reminder is that first we need to set this equal to 0. So subtract 5 from both sides. Now your a is 1, b is 3, c is negative 5. So x equals negative b, negative 3, plus or minus the square root of b squared, 3 squared is 9, minus 4 times a is 1, times c is negative 5, all over 2 times a is 2. Clean it up. X is negative 3 plus or minus the square root of 9 plus 20. Negative 4 times 1 is negative 4 times negative 5 is positive 20, all over 2. X equals negative 3 plus or minus the square root of 29 all over 2. And now you want to see if you can simplify the square root of 29. It's certainly not a perfect square, so you're going to have this irrational answer. And there's no other perfect square number that divides into 29 nicely, so it's not simplifiable either. So you're done. Your roots are negative 3 plus root 29 over 2 and negative 3 minus root 29 over 2. And you can leave it alone, just like this. It shows the two roots quite clearly. Okay, for our third example, we will solve 25x squared minus 8x equals 12x minus 4. Again, we need to set this equal to 0 first, so we'll subtract 12x from both sides and add 4. 25x squared minus 20x plus 4 equals 0. Okay, x here, your a value is 25, b is negative 20, and c is 4. So x equals your negative b, negative negative 20 is 20, plus or minus the square root of b squared, negative 20 all squared is 400, minus 4 times a is 25, times c is 4, all over 2 times a, 2 times 25 is 50. So x is negative b, 20, plus or minus the square root of, I have 400. Negative 4 times 25 is negative 100, times 4 is minus 400, all over 50. So here x is 20 plus or minus 400 minus 400 is 0, the square root of 0 over 50. The square root of 0 is just 0. So when I add 0 to a number or subtract 0 from a number, it stays the same. So really it's just gone. So here I have x is 20 over 50, which reduces to 2/5. So notice when the number under the square root is a 0, we get what seems to be one answer. Now keep in mind what we talked about in class last week. My highest exponent is 2, so I need 2 answers. So what really happened here is I have 2 equal roots. I have 2 answers and they're both 2/5. Had you factored this, your factors would have been the same, and so you would have gotten 2 factors that were identical. You would have solved it twice and gotten the same root both times. So just because it appears that there's only one root, there's actually 2 equal roots. Okay, one more example. For our final example today, we'll solve negative x squared plus 4x equals 13. Okay, once again, we need this set equal to 0. Some people don't like your squared term to be negative, and I'm one of those people. I prefer that my squared term is positive, especially if I want to factor or complete the square. So I'm just in the habit of always making my x squared term positive, making my a value positive, so that I'm consistent all the time. So I'm actually going to make my left side the 0 side here. So I'll subtract x squared and subtract 4x from both sides. So I'm going to add x squared to both sides and subtract 4x and keep that positive 13 there. So now I'm in standard form. I can use my quadratic formula. X equals negative b, negative negative 4 is 4, plus or minus the square root of b squared, negative 4 squared is 16, minus 4 times a is 1, times c is 13, all over 2 times a, 2 times 1 is 2. So x equals 4 plus or minus the square root of 16 minus 4 times 1 is 4 times 13 is 52, all over 2. clean it up. X is 4 plus or minus the square root of, well, 16 minus 52 is going to be a negative number. And let's figure out what that is. 52 minus 16 is 36 all over 2. Now, we have a negative under the square root. Until last week, we'd have to stop there and say no real roots, but now we know how to deal with imaginary numbers. And so I can clean this up more. X is 4 plus or minus. The square root of negative 36 is 6i all over 2. 2 divides nicely into both 4 and 6, so we can clean this up more and call this 4 divided by 2 is 2 plus or minus 6i divided by 2 is 3i. And there are your roots. So notice again, when you get a negative under the square root, we have imaginary or complex solutions. That's it for today. Have a great night.